So a couple of examples of how our explorations could really help us. We could graph these two equations. We have the first equation is y equals 2 times x minus 5 squared plus 3. Normally that would be pretty tricky, and you'd probably want to use your graphing calculator, but if you recognize a couple things about this, for example, I know the vertex just based on that equation, and the vertex is going to be 5, 3, because I have my h value here and my k value here. So I'm going to first plot that point 5, 3. 1, 2, 3, 4, 5, 1, 2, 3. Second thing I'm going to look at is the fact that this a value is positive, and it's greater than 1, so that means that it's going to be slightly skinnier than the normal parabola that we're used to graphing. And so I might just put in some points here. So if I have y equals 2 times x squared, actually when x is 1, y would be 2, so it would go up doubly as fast as what it normally would go up. So I might draw this graph to be like this. And again, this is just a sketch. I didn't really have to plot any points. I'm just remembering the vertex and that it's slightly skinnier. It faces upwards because it's positive. So I'm looking at the equation to get an idea. Now what if we don't have y equals x squared? What if I have y equals square root of x plus 2 minus 4? Then I would remember the the presentation that was given by students on the parent graph of y equals the square root of x, which was sort of, it looks like kind of half of a parabola laying on its side. So it's this solid black line right here. And h and k work exactly the same way. They're kind of a vertex. It's more of a starting point now. So we said hk is the starting point of the graph. So wherever h and k are, that's where you're going to start your graph, and then you're just going to do a half a parabola. Again, a was a value that, as a was greater than 0, this parabola got wider or bigger, this half. So I put in dashed lines here. The bigger a gets, the wider that curve is going to be. And then for like fraction like 0.1 or 0.5, between 0 and 1, a is going to just start to lay flat out. When it equals 0, it would be a straight line. If a becomes negative, all of a sudden we have the curve going this way. So let's go back to the problem that we were given to graph. Okay, y equals the square root of x plus 2 minus 4. And let's make that just slightly more interesting. Let's put a negative 1 before that. So negative 1 times the square root of x plus 2 minus 4. And notice that minus 4 is not under the square root symbol, so there's nothing you can combine there. So again, the first thing I recognize is that my vertex is at negative 2, negative 4. Or the starting point in this case. I guess it's not really a vertex. Negative 2, negative 4 is my starting point. The parabola is going to be, or the graph is going to be about the same width as a y equals the square root of x1 that we saw over here, but it's going to open down instead of opening up. So I'm going to come over here, and I usually like to put in just a couple of points to guide me. And then I'm going to draw that little piece of a graph. Okay? And so those are the things that we learned in this chapter.